So in Module 16, you've been looking at different ways to solve quadratic equations. You looked at using the square root method, and you also solved equations by factoring. Now, sometimes these methods may not work. You might not be able to factor an equation, and you saw that in some. So, the quadratic formula is another method that you can always use to solve any quadratic equation. What is a quadratic formula? It's a formula that looks like this. It looks complicated, but it's not. It's just a matter of knowing what the b value is. Notice you have b values, and notice you have a values and c values in this formula. So once you know the a, b, and c values, then just substitute them in, and it just becomes order of operations, and you can solve it that way. So let's look at what they told you in the book. So to start with, the quadratic formula can be used to solve any quadratic equation that's written in standard form, and that's important. It must be written in standard form. And remember what standard form is. Standard form of a quadratic equation is one where the equation is written equal to 0. And notice here you have your a, b, and your c values. Ax squared plus bx plus c. So whatever the coefficient is with the x squared is your a, the coefficient with the x is b, and then the constant is the c. Standard form means it's got to be written equal to 0. So in the first example, 2x squared plus 3x minus 5 equals 0. Notice it's already written equal to 0, so you don't have to rewrite the equation. Now it's just a matter of finding your a, b, and c values and substituting them correctly. And using the quadratic formula, it's just a matter of just careful substitution. So looking at this equation here, your a value is the 2, because that's the coefficient on the x squared. Your b value is the 3, and since it says plus 3, it's positive 3. And then your c value, since it says minus 5, that means your c value is negative 5. So you have your a, b, and c values. Now, just carefully substitute them into the quadratic formula, and that's what they did right here. Negative b, so if b is 3, negative b became negative 3. And then it's plus or minus the square root of b squared minus 4ac. So b is 3, so 3 squared would be your b squared. And then minus 4, your a value is the 2, and then your c value is the negative 5. So they just found the a, b, and c values and substituted them in. And then the denominator is 2 times a. And since your a value is 2, it just becomes 2 times 2. At that point, it's just a matter of simplifying everything that you can. First, they simplified everything under the square root symbol. So 3 squared is 9. So that became 9 minus, and then they multiplied 4 times 2, which is 8. 8 times negative 5 is negative 40, so 9 minus negative 40 is the same as 9 plus 40. That's where the 49 came from. And then 2 times 2 gave them 4 in the denominator. Well, the square root of 49 is 7, so it became negative 3 plus or minus 7 over 4. So that gives you the two equations. So that means x can be negative 3 plus 7 over 4. That's what they wrote right here. Or x can be negative 3 minus 7 over 4. And that's what they wrote right here. Negative 3 plus 4 is 4. So the first one would be 4 over 4, which simplifies to 1. So they got x equals 1. And then for the second one, negative 3 minus 7 would be negative 10 over 4. And negative 10 over 4 simplifies to negative 5 over 2. So that's why they wrote that the solutions would be 1 and negative 5 over 2. On example B, here is your quadratic equation. So you first have to think, is it written in standard form? No, it's not. It has to be written equal to 0. Two different ways to do this. Notice what they did. It looks like they kept the x squared and the minus 4 over here, and they wanted to move the 2x over to make this side equal to 0. So that just means they subtracted 2x from both sides. And that left them with x squared minus the 2x and the minus 4. And all of this side is now equal to 0. Now you might be thinking, could you have done it the other way? Could you have subtracted this side, put it over on the other side, and made this side equal to 0? Yes, you could have. You could have subtracted x squared from both sides, and that would leave you with negative x squared. And then you would also have to add 4 to both sides. Well, if you subtract x squared from both sides, you have negative x squared over here. You still have the plus 2x. And then once you add 4 to this side, it would become plus 4. And you've written it in standard form that way. Now looking at it this way, what would your a value be? It would be the coefficient on the x squared, which is negative 1. So a would be negative 1. Your b value would be the plus 2, which is 2. And your c value would be the plus 4, which is 4. The way that they did it, their a value is positive 1. The b value is negative 2, and the c value is negative 4. It doesn't matter. When you substitute, either way, when you substitute these values into the quadratic formula, in the end, you would still get exactly the same answers either way that you first solved or wrote the equation in standard form. But let's go back to the way that they did it. So now that they wrote it this way, they have their a, b, and c values, and then it just becomes careful substitution. You don't have to memorize this formula. You just have to have it ready to know how to use it. And after you practice a lot, you're going to realize you do have it memorized. So you just have to substitute. The a value is 1, so b value is negative 2, c is negative 4. So negative b value is negative 2, so it becomes negative of negative 2 plus or minus b squared minus 4ac. The b is negative 2, so negative 2 squared minus 4 times the a value, which is 1, and the c value, which is negative 4, all over 2 times a, and the a value is 1. Now just simplify it. Negative of negative 2 gave them positive 2. When you simplify everything under the radical, that becomes 4 minus 4 times 1 is 4. 4 times negative 4 is negative 16. So 4 minus negative 16 is 4 plus 16. That's how they got 20. And then 2 times 1 is 2 for the 2a. So that can be 2 plus square root of 20 over 2, or 2 minus square root of 20 over 2. How did they end up with these two answers? Remember, you can simplify rational expressions. Square root of 20 is the same as square root of 4 times the square root of 5. So you can think of that as 2. Looking at this one, you can say x equals 2 plus, and I'm going to rewrite square root of 20 as square root of 4 times square root of 5. And then that's all over the 2. Well, what's the square root of 4? Square root of 4 is 2. So that becomes 2 plus 2 radical 5 all over 2. And then for the other one, 2 minus, it could be 2 minus square root of 4 times square root of 5 over 2. And that simplifies to 2 minus square root of 4 is 2, radical 5 over 2. Now at this point, remember, you can simplify these fractions because the 2 and the 2 all have common factors of 2. So you can divide each of those terms by 2. And when you do that, 2 divided by 2 is 1. When you divide this by 2, the 2 cancels out, and that just leaves you with radical 5. And then in the denominator, 2 divided by 2 is 1. And then over here, you would have, instead of 1 plus radical 5, it would become 1 minus radical 5. And 1 plus radical 5 over 1 is the same as 1 plus radical 5. And over here, 1 minus radical 5 over 1 is the same as... So that's how they got these two answers as the simplified form. Let's look at a couple of examples, and you're going to see how easy this is. So it tells us to solve the quadratic formula. First, we need to make sure it's in standard form. It's not. So I can either move the 5x plus 2 over to the other side, or I could subtract the 3x squared and put it over here. I like to keep the a value positive, and you'll see that in most math books, and math teachers will say the same thing. So I'm going to move the 5x plus 2 over to the other side and make this side equal to 0. So that means I'm going to subtract 5x from both sides, and then we're going to subtract 2 from both sides. So when we do that, this all becomes 0, and then on this side we have 3x squared minus 5x, and then we have the minus 2. So that got rid of all of this, so that side's all equal to 0. So now we have it in standard form. So we now need to know our a, b, and c values. A is the coefficient on the x squared, so our a value is 3. Our b value is the number with the x. It says minus 5x, so that means b is negative 5. And then c is negative 2 because it says minus 2. Now we're just ready to substitute into the quadratic formula. The quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So now just to substitute, we're going to say x equals, right, b is negative 5, so it's going to be negative b plus or minus the square root of b squared. Well, b is negative 5, so it's negative 5 squared minus 4 times the a value. The a value is 3 times the c value, and the c value is negative 2. So our first step was to just substitute everything, and then 2 times a, the a value is 3. That's what you should always do first. Don't try to do it all mentally. First do your substitution and then start simplifying. Negative of negative 5 is 5, so it becomes 5 plus or minus. And then to simplify everything under the radical, negative 5 times negative 5 is 25, minus 4 times 3 is 12, 12 times negative 2 is negative 24. So 25 minus negative 24. 25 minus negative 24 is 49. All over 2 times 3, which is 6. Alright, so square root of 49 is 7, so we can say x is equal to 5 plus 7 over 6, or x is equal to 5 minus 7 over 6. Well, 5 plus 7 is 12. 12 divided by 6 is 2. So x equals 2, or over here, 5 minus 7 is negative 2, and then negative 2 over 6 simplifies to negative 1/3. So by using the quadratic formula, we were able to solve that equation. Values of x can be 2 or negative 1/3. And if we were to take those values and substitute them into the original equation, we would see that it makes it true. And just to quickly check that, like if x is 2, 5 times 2 is 10, 10 plus 2 is 12. And then on the other side, if x is 2, 2 squared is 4, 4 times 3 is 12. And then the same if x were negative 1/3, you could substitute negative 1/3 and it would make both sides of the equation the same. Let's look at one more. 2x squared minus 8x plus 1. This one's already written in standard form. So your a value, remember, ax squared plus bx plus c equals 0. So our a value is the 2. Our b value is negative 8 since it says minus 8x. And the c value is 1. Now just substitute. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So to substitute this, our x equals, remember always write x equals, so x equals negative b, so if b is negative 8, it's going to be negative of negative 8, and then plus or minus b squared, it's going to be negative 8 squared, minus 4 times a, which is 2, times c, which is 1. Now that all needs to be over 2a, a is 2. At this point, it's just a matter of simplifying. X equals negative of negative 8 is 8. Negative 8 squared is negative 8 times negative 8, which is 64. And then minus 4 times 2 is 8. 8 times 1 is 8, so that becomes minus 8. So 64 minus 8 is 56. And then your denominator is 2 times 2, which is 4. Now, can we, 56 is not a perfect square, but can we simplify this? Square root of 56 is the same as square root of 4 times the square root of 14. So we're able to take out a perfect square factor of 4. Square root of 4 is 2, so that can be written as 2 radical 14. Alright, so I'm going to just rewrite that as 8 plus or minus 2 radical 14 over 4. And can we simplify this? Look at the 8, the 2, and the 4. Those all have a common factor of 2. You can divide everything by 2. So I'm going to say then that x equals 8 divided by 2 is 4, plus or minus. Well, when we divide this by 2, that just turns into a 1, and it just leaves us with radical 14, and then 4 divided by 2 is 2. So that's a perfectly acceptable way to write your answer. You can just write it as 4 plus or minus the square root of 14 over 2. Or you could write it as 4 plus the square root of 14 over 2, or 4 minus the square root of 14 over 2. That would also be correct. You could write it like this, or you could break it up and say x equals 4 plus radical 14 over 2, or 4 minus radical 14 over 2. That is also a correct way to write the answer. And that is how you use the quadratic formula to solve these equations. So that's what you'll be working with today on your assignment.